So previously we have learnt finding the uh, regression by actual mean, right? Now here, okay, now here we are supposed to utilize or use assumed mean. So we have learned, we have two types of problems. One is from actual mean, the other one is from assumed mean. Okay, so let us see how to solve the problems using assumed mean. And why do we use assumed mean? Anybody who can answer that? Why do we use assumed mean suddenly? We were getting values using the actual mean. But why do you think we are supposed to use assumed mean? Assumed mean is taken for the calculation because the actual mean, if you get points, okay, say suppose you get 35.7. Now when you get points and when you take deviations, that is x minus x bar, when you take deviations, in every deviation you are going to get points again. And then when you square that numbers, that is x minus x bar will be small x. Now when you square this small x, again you will get more number of points. Like this, the decimal numbers will increase more and more, which will make it very tedious for us to solve the complete problem. That is major reason why we take assumed mean, and this assumed mean will be from the series given to us, so it will help us to avoid the decimal points and directly do the problem easily. So that is the major reason why we use the assumed mean. Understood now? So whenever you have the actual mean coming to be in fractions, or if you have them with decimals, then in such scenario the calculations will become very difficult because the points goes on increasing. So that is the major reason why we'll be using assumed mean to take the deviations here. Okay, now in the assumed mean, when you consider assumed mean, then you'll have a different formula to calculate. Now, when this assumed mean is taken, now how do we calculate the regression coefficient? Now, regression coefficient of y on x. So, this is our first equation. Okay, regression coefficient y on x, which is known as byx. Okay, so this is your regression coefficient. This is how we denote regression coefficient. In that case, we will be using this formula, that is byx is equal to n into dx dy minus dx into dy divided by n dx square minus n into sigma dx square minus sigma dx whole square. Okay, so I hope you remember this formula. We had used similar formula in the previous chapter. Okay, so here for y on x you will have yx, and then dx into dy, this multiplication is common. Then you have dx into dy, then whole divided by dx square. Since it is y on x, you will have in the denominator dx square and dx whole square. Okay, then when you take up the other equation, that is x on y, if you compare these two, the numerator of these two formulas are same, that is n into sigma dx dy minus sigma dx into sigma dy. But when you take the denominators for y on x, you have x in both the places. In x on y, you have y in both the places. Okay, so this is both the formulas to calculate regression coefficient. Now here dx, what does this dx mean? Dx is nothing but x minus assumed mean of x, dy is nothing but y minus assumed mean of y, and n is the number of items. Ax is assumed mean of x series, ay is assumed mean of y series. Okay, so this is the major formula that we are supposed to consider. So any doubts in the concept about why do we use assumed mean? Okay, now let us see a problem. So I think we'll be able to understand it better with the problem here. Okay, so the first problem, the following table shows the age x. Okay, the age is denoted by x and blood pressure is denoted by y. Okay, so this is age and this is the BP, blood pressure of 6%. So which means n is equal to 6, and they've given the data here. Obtain two regression equations. Also find the expected blood pressure of person who is 50 years old. Now we are supposed to get y on x equation and x on y equation. So these two are both regression equations. And apart from that, we should also expect that blood pressure. Okay, we have to find out y when x is equal to 50. Now how did I get to know that? Now if you see, blood pressure is y, okay, of the person who is 50 years old. Now x is given to us, that is age of the person, that is 50. So when x is equal to 50, we are supposed to predict y. Sorry, let us continue. Now going to the solution, formulation of regression equations. X, we have written it down directly, y is written down as it is. Then before going to next steps, let us, as usual, how we analyze what are the important values, let us analyze that in the previous equation. Now first let us consider only for y on x. Now for y on x, the first important thing is n is given to us in the problem. The next important value is sigma dx dy. Okay, and then we have to find dx and dy first in that case. Now once you find dx and dy, then we are supposed to square dx and dy. So then you will have dx square dy square. Then after that only we will be able to calculate dx into dy. So first we have to calculate dx separately, dy separately. Then we have to square dx and then dy, and then we'll have to multiply dx into dy. Okay, then apart from that, we want n, which is already there in the question. Now let us see in the problem. X is there, y is there, then dx. Now dx, for dx we have to consider assumed mean. Now in this, since it's a first problem, they have also calculated normal mean to show us the difference. Now how to calculate normal mean? Just add all the values of x and divide it by 6. Even for y also, Even for y also, you're supposed to add up all the numbers and divide it by 6. Okay, so coming here, you have x bar is equal to sigma x by n 317 by 6, which is 52.83. If you see here, you get point. Again for y bar also, you get point, that is 63.33. Okay, so here that is why we are not taking the actual mean, because if you take 53.33, again you get 0.33.7, all these point values you get once again here, and later when you square them it will become very difficult for us to add up and maintain the numbers. So that is why instead of the actual mean, let us assume one number from x and put them as assumed mean. Similarly, from y also we will assume one number and put that as assumed mean. Okay, so dx is equal to, now here first assumed mean what they have considered is 52. Okay, so dx is equal to x minus assumed mean, that is 52. So when I calculate the difference between 52 and the assumed mean 52 here, it is 0. Then again 45 minus 52 is minus 7, 36 minus 52 is minus 16, 72 minus 52 is 20, 65 minus 52 is 13, 47 minus 52 is minus 5. Okay, and then when you add these up, you get summation dx as 5. So here there is no hard and fast rule of getting sigma x is equal to 0 and all that. So sigma dx, whatever values are given, just add them up, you get plus 5. Okay, then the after that let us find out dy, that is the deviations. Now deviations, out of these numbers again we have to assume one number to be an assumed mean. So here we are assuming 60 as assumed mean. You can take any number, first number, last number, middle number, 75, 79, 62, any number for y you can consider here. So we have considered 60. So 62 minus 60 is 2, 53 minus 60 is 7, 51 minus 60 is minus 9, 75 minus 60 is 15 plus 15, 79 minus 60 is 19, 60 minus 60 is 0. Okay, so once you get all these deviations, then when you add it up, your next important number is summation dy is equal to 20. Okay, then dx, okay, so this value of dx, whatever we have found out, if you find the square of them, or if you square all these numbers, then you get dx square. Okay, so that is summation dx square is equal to 899. How did I get 899? I just added all these numbers after finding the square. Then similarly for dy also we have to find the square. So square all these numbers. So you get dy square. So dy square, the total is 720. Now once you are done with all the four columns, that is dx, dx square, dy, dy square, and the last important value to calculate is multiplication of dx into dy. So multiply these two columns, 0 into 2, minus 7 into minus 7, 16 minus 16 into minus 9, and so on. So when you multiply these two deviations, dx into dy, then you get the last important value, that is summation dx dy. Okay, so from the problem, what are the major things that we have found out? First, we wrote down the x values and y values. We assumed one of the number to be assumed mean from x and one number from y to be assumed mean for y. Then we calculated deviations from x, that is x minus assumed mean, and that is denoted as dx. Then after that we squared all these different deviations, and that is known as dx square. Then coming to y, dy, here again we calculated the differences or the deviations from the value of y by taking the assumed mean of 60. Then after that these values again we squared them up to get dy square. And lastly and finally we multiplied the deviation of x, that is dx, with dy, that is deviation of y. So dx dy we multiplied and we got the complete values. So that will be our all these will be our important values for calculation. So any doubts in the table calculation? Okay, so let us go on further for uh, okay, so let us go on further for formula calculations. Now, as usual, we are supposed to calculate two regression equations. Now, two regression equations is y on x and x on y. So we will solve it simultaneously here, next one after the other. Okay, so first we will solve the equation of y on x. So what is the equation on y on x? Y minus y bar is equal to byx into x minus x bar. Okay, so this should be the regression equation which we are supposed to fill it up. Okay, now in here in this equation the value of byx is given by this complete formula. Okay, so once we find out the value of byx, then we know the value of y bar, we know the value of x bar, and then we will be able to form an equation completely. So byx is equal to n into sigma or summation dx dy minus summation dx into summation dy whole divided by n into summation dx square minus summation dx whole square. Now n is equal to 6. Now how did we know n is equal to 6? If you see here, they have given it's a blood pressure of 6%. So that is why n is equal to 6. Then dx dy, so if you see the values here, dx dy is 740, dy square is 720, dy is 20, dx square is 899, and dx is 5. So we are using all these 5 important values in the formula. Now coming to the formula, n is 6, dx dy is 740, yeah, 740 minus dx is 5, sigma dy is 20 whole divided by, since it is y on x, in the denominator it will be x only. Okay, so 6 into dx square is 899 minus dx whole square, so dx is 5 whole square. Now next step, 6 into 740 is 4440 minus 5 into 20 is 100. Next line, 6 into 899 is 5394 minus 5 square is 25. Then next step will be subtraction of these two values. 4440 minus 100 will be 4340 divided by 5394 minus 25 will be 5369. Now once you divide these two numbers, the value of byx is 0.8083. Okay, 0.8083. Now once we got the value of byx, now let us form a equation. Now for forming an equation, we know what are the values of y bar and x bar also. Okay, now y bar and x bar is not your assumed mean but your actual mean. Okay, that is the major twist here. So you cannot, only for the calculation you'll use the assumed mean, but for forming the equation you must use the arithmetic mean. It doesn't make too much of difference because assumed mean is one value which is in the number itself or in the series itself. So it doesn't make too much of difference and you can consider the assumed mean. But when it comes to equation calculation, you have to calculate the actual mean and consider the actual mean only. Okay, so y minus y bar is equal to byx into x minus x bar, and y minus y bar, which is already calculated here, 63.33, is equal to byx is 0.8083 into x minus x bar is 52.83. Okay, then next step we are supposed to remove the brackets. Now once you remove the brackets here, it will become y minus 63.33, and here when you remove brackets you are supposed to multiply the expression with this constant. So 0.8083 into x will give you 0.8083x, then minus 0.8083 into 52.83, that will give the result as 42.7. Now once we know this expression, now let us take this constant of minus to the other side and make it plus. So minus 63.33, if it comes to the other side of equal to, it will become plus. So y is equal to 0.8083x minus 42.7 plus 63.33. So this together, this constants, when you add them up, you will get 20.63. Okay, so your first equation is y is equal to 20.63 plus 0.8083x. Fine. So this is the first regression equation, that is y on x. Any doubts in the first equation? Okay. So let us solve the other equation, that is x on y. So first one was y on x, now it is x on y. Now in x on y, now in x on y, x minus x bar is equal to bxy into y minus y bar. This will be the main regression equation. Now here we are supposed to calculate the value of bxy, which is given through this formula. The formula stands like this: n into summation dx dy minus summation dx into summation dy whole divided by n into summation dx y square minus dy dy square minus dy whole square. Okay, so if you see here, on y on x, everything in the denominator is x, but on x on y, everything in the denominator is y. So let us put all the numbers here. So 6 into 740 minus 5 into 20. So which is the numerator value will remain same. Now coming to the denominator, 6 into dy square is 720 minus dy is 20 whole square. Now the denominator values will remain same. 4440 minus 100, 4340. Now coming to denominator, 6 into 720 is 4320 minus 20 square is 400, and 4320 minus 400 will give you 3920. Now finally the value of bxy, once you divide these two numbers you get 1.107. So once you get the value of bxy, that is the coefficient that is required. So now we will apply that into the formula. Okay, regression coefficient will be applied into the formula. Now this it will be applied into the equation. Now this equation is x minus x bar is equal to bxy into y minus y bar. If you compare these two equations, just understand the difference between them. Okay, so x minus x bar is 52.83 and y minus y bar is 63.33 and bxy is 1.107. Okay, then next step we will remove the brackets. Here we have to do the multiplication. So 1.107y into 1.107 into 63.33 will give us 70.11. So next step after this minus value of 52.83, take it on to the other side and make it as plus 52.83. Now once we are done with this, the final equation of regression, that is x on y, will be x is equal to minus 17.28. How did they get 17.28? Minus 70.11 plus 52.83, you'll get 17.28. Okay, minus 17.28 plus 1.107y. Or you can also write this equation as x is equal to 1.107y minus 17.28. Okay, this also, in this way also you can write this equation. Okay, so this is the second equation, that is regression equation of x on y. Any doubt in this equation? So everybody understood this. Okay. Now let us solve the last one value in the problem. That is, if you see the question, they have given us, we have to also predict one value when the age is 50. Okay, so we have to predict the blood pressure of one person whose age is 50. So if you see here, also find expected blood pressure of person who is 50 years old. Now we know the value of x and we are supposed to find the value of y. Now in this case, which means that we are supposed to use the equation y on x. Okay. So if you see here, y on x, which we have solved here, y is equal to 20 plus 20.63 plus 0.8083x. Now if we use this equation, we know the value of x. Okay, which means we can predict the value of or find out the value of y. So let us see, by applying in the place of x, we will apply 50. Okay, so expected blood pressure when x is equal to 50 years is y is equal to 20.63 plus 0.8083x. Okay, in the place of x, I am replacing it by 50. Now, once I do that, I will get the y value to be 61.045. Okay, so the y value is 61.045. So when x is 50, the blood pressure, or when the age is 50 for that person, the blood pressure of that person is 61.045. So that is how expected blood pressure is being found out in this problem. So whenever you see a regression problem in the examination, usually they will ask you to predict. First type of problems, they'll only ask you to find the regression equations. Okay, so you can just find these equations and leave it until there. The second type of problem, they will also give extra questions like this, where x will be given and you will have to find y. In that case, use y on x equation. Suppose if they have given y and you have to find out x, then you must use x on y equation only. So however the data is given, according to that you have to analyze and find out the value. Okay, so any doubt until here in this problem? Any part of it you want me to explain it again? Okay, now let us quickly see one more problem here. Given the bivariate data and they have given us the values of x as well as y, then fit a regression line of y on x and hence predict y if x is equal to 5. So first equation, regression line is nothing but regression equation you have to find out. Okay, so that formula which we usually use, that is x minus x bar is equal to b into y minus y bar. So that is a regression line formula or equation. So here we have to find out the equation first, and after that we are supposed to predict certain values. Okay, so first regression line is y on x, and we have to predict y when x is given to us, and then fit a regression line of x on y and predict x if y is 2.5. So all the procedures remain same. So let's give the heading formulation of regression equations, where the x value is taken, y value is taken, and this is, we are solving through this we are solving through assumed mean method. Now in assumed mean we are supposed to take one value from x and so one value from y. So before that we all have to consider the total of x and divide them by the number of data. So the number of data is 1 2 3 4 5 6 7 8. So we have 8 number of data. So 23 divided by 8 will give you a point here. So x bar will be a point. Again similarly, if you take y, you might get one complete value but not always. Okay, so there's some mistake here, we will check that. Okay, so coming to this value here. Okay, coming to the deviations, the first assumed mean that we have considered here is 3. Okay, so 3, you can take this 3 also and this 3 also, anything is fine. Okay, here it doesn't make much difference even when the numbers are repeated. Fine, so that is x. Then once you find the deviations from this x, you get summation dx. Now after that you are supposed to find out the value of dx square. So square or this column, you get dx square. Now going on further for the y, it is 2. Okay, it is not 20. It is not 20. There's a typing mistake there. It is 2. Now once you take y minus 2 and you find out all the values for this, okay, or all the deviations from this, the total value of sigma dy is 0. Then dy square, is calculating the square of this column, that is dy square. Okay, then dx into dy. Now finally you are supposed to multiply this dx and dy column to get dx into dy. Now once we get all the important values, let us go on and put or form the equations. Now again here they have calculated the actual mean, because we require the actual mean calculation. Just a second. We require actual mean calculation for this equations here. Okay, so here the n for us is 8. Okay, which means y bar is 2. So you can take the same number here as y bar, or you can take any other number, it's okay. So first we will solve byx and bxy here, and then only we will be able to form the equations. So first equation y on x, that is y minus y bar is equal to byx into x minus x bar. Okay, in this we are supposed to calculate byx, that is nothing but n into summation dx, n into summation dx dy minus summation dx into summation dy, whole divided by n into summation dx square minus summation dx whole square. So in the denominator you have x. Then going on further, n, the value of n is equal to 8. So 8 into dx dy is minus 10. Then minus summation dx is minus 1, dy is 0, whole divided by 8 into 33 minus of minus 1 square. Okay, so here 8 into minus 10 is minus 80, minus 1 into 0 is 0. So minus 80 will remain in the numerator. Coming to the denominator, 8 into 33 is 264 minus minus 1 square. So minus 1 into minus 1 is equal to plus 1. Okay, so minus this whole expression is plus 1, so that remains. Then minus 80 divided by 264 minus 1 is 263. Then is equal to minus 0.3042. So once you divide these two numbers, you get the byx value. Now that byx value should be put up into the into the equation here to derive the y on x regression equation. So y minus y bar is 2, x minus x bar is 2.875. Okay, so 2.875 is considered. Now if you observe, the assumed mean is taken very nearest number, the nearest number to the actual mean. Now in our assumed mean for x bar, the assumed mean which we considered was 3, and for y bar we still considered it as 2 only. So some nearest number if you take, it will be easy for you to understand. Okay, so y minus 2 is equal to this byx coefficient, that is minus 0.3042 into x minus x bar. Okay, so next we are taking out the brackets, which means we are supposed to multiply these two numbers and these two numbers. Then we get an equation saying y is equal to 2.8745 minus 0.3042x. Fine. So this is first equation of regression, that is y on x. And in the question they have asked us to predict y if x is 5. Okay, so in the place of x, okay, in the place of x here we have to substitute 5, and then we are supposed to calculate the value of the y here, and that is what we have done. So in the place of x we have put 5, and then when you multiply and then subtract here, you get the prediction value of y. Okay, so this is the first set of regression equation. The second set of regression equation is x on y. Now in x on y, you have supposed to calculate bxy, and once you add on, or once you put on all the numbers into that, here be careful with zeros. Okay, anything multiplied by 0 is 0, anything divided by 0 is also 0. Okay, so here you get minus 80 and 8 into 36, because minus 1 into 0 is 0, 0 square is also 0. So you get minus 80 into 288, which is equal to minus 0.2778. Fine. Then the regression equation here is x minus x bar is equal to bxy into y minus y bar. Now here again we are substituting the x bar and y bar values, and then the coefficient value we found out. And once we remove the brackets and multiply and do the simplification, we get the equation x on y, that is 3.4306 minus 0.2778y. Okay, so that is what we get. Then again here also, going back to the problem, they have asked us to predict x when y value is given to us, and y value is 2.5. So here in the place of y, we are supposed to replace that or substitute that with 2.5. Okay, so 2.5 into that value, and then you will be able to predict the value of x. So once you do all this calculation, the value of x when y is given is 2.7361. So this is another type of problem which can be asked for 14 marks. Any doubts in this problem? Everybody understood? Okay.